Usually I spend a lot of time on this slide because I try to put in those things which stay permanent because titles changes, designation change, companies change. But these are a few things which stay constant. But I won't spend much time now putting up out there. But I would like you to only focus on the last point there. Says imaginary TED Talk. So if you ever find me sitting somewhere and talking to myself, don't think that I'm a sane person or eligible person to go to a mental hospital. It's just me giving my imaginary TED Talks with my imaginary audience there. So that's just a fun fact about me. But yeah, I spend a lot of time with communities. Recently, I think last week we came back organizing React India. So have been organizing a few conferences, React India, JS Conf India. I organize MongoDB user group in Pune, some open source conferences in Pune. So in case if you ever are willing to attend there, feel free to reach out to me and maybe see you there in any one of the conferences. But yeah, that's all about me. I think I was reading the description which was mentioned on the website. It was a bit, of course, it was ChatGPT. There's no denying in that. But I just wanted to set the tone here that this talk isn't much about like someone coming here and showing how much they know. It's more about helping you learn a topic. So that is why I'll say that it's a brainstorming talk, in the sense that when you leave the room and go back, because usually I've seen people putting posts that rather than sharing questions, I've seen people putting a plan to implement. So maybe these type of things, right? I mean, rather than those ChatGPT generated content. So it would be very meaningful for me, and I would be getting so much value out of it, and so will the audience who's watching your post. So, and that's what I wanted to set the tone here. That it's a more of a brainstorming talk rather than just showing how much I know. So, all right. So to start with, there are two phases or two parts of this talk. So the first part will be looking into change direction, signals, and all of those topics. The second would be looking on building side of the applications. So before I start, I just want to understand the level of the room that we have here. So how many of you are like front-end developers already? Okay, I think most of you. And how many of you use Angular? Or like familiar with Angular? Nice. So it's a mixed base from what I can see. Few of you are using, few of you are familiar, and few of you are wanting to start. So the topic here, it will need a bit of familiarity with Angular. That was the prerequisite, but it's okay. You can just learn those jargons from here and then go back, and if you try to look out, it's not that difficult. It might seem like way above it, but it's not, to be honest. So let's start with revisiting few things which will help us build or understand the topic today. So there's a very not famous, but a very common thing that's used in most of the frameworks. It's called change direction. So for those who, no, I'll repeat it. For those of you know, it's good, but for those of you don't know, I'll just try to summarize it faster so that it's equal for them also. So if you see when we say that or when we talk about change direction, so it's a process. It's a completely process, end-to-end process. So what does it do is it's used by mostly all of the front-end frameworks, let it be React or it be Angular, but it's used by all of them. What it helps is it helps you to understand the which DOM element is getting the change, and based on that, what does it need to render, what does it need to update, it decides accordingly. So that's what basically change direction is, that whenever a change is registered or it's subscribed to, let's say, an object, and whenever it gets an new change in that, so what actions does it need to perform after receiving that change? So as I said, like different frameworks, most of the frameworks try to implement this, and all of them try to implement in very different way. In case if you might have heard of virtual DOM, which React uses. So it's basically, it creates like two copies of the same tree, and then based on the, it makes changes only in the one tree, and then it compares with the original tree, and then accordingly it updates the virtual DOM. So React uses virtual DOM. Angular uses something called as Zone.js. It uses a different library. It heavily depends on that. It still uses that. So why I use still, you'll get to know in the slides ahead. But it uses a library called Zone.js, and based on that, it accordingly updates and renders the components. So by default, it was Zone.js, but now with the release of version 16 and version 17, I think the current version is version 19. They'll be releasing version 21 in 2 days, so you never know what new comes. But after version 16, they stopped, or they started giving flexibility to the developers to change it from Zone.js to something else, and tried pushing signals. At the core, it still uses Zone.js, but they gave the users a permission to Zone.js. Do you have a question? अच्छा मैं बहुत फास्ट बोल रहा हूँ ओके कूल ठीक है I'll try to be a bit slower. So do you want me to repeat the whole slide again? No, right? Okay, cool. So as we understood, Angular uses something called as signals.js signals. It uses zone.js library to check if there's any change in the DOM or not, right? Accordingly, it decides. Then basically, what it'll do is it will start from the root node. It will traverse through the whole tree, check which element has received changes, and then accordingly, it will traverse from up to down and update the DOM tree. So basically, what I'm trying to say is it will try to scan from top to down. Even though the change was made in the leaf node, it will still scan from top to down, like from root node start. So sometimes those changes might not be necessary. So we'll understand more, and that's what signals is for. Um, so to understand that, we will also look and what the evolution of change detection went through. So if you all know Angular JS, it was like the very first version that Angular had released, which people don't even consider Angular nowadays because it's very different from what Angular is today. But I know that maybe some projects are still live in that. So that was Angular JS, purely JavaScript. It used to have something called as dirty checking, and based on that, it used to call a method digest, and accordingly, it used to check whatever changes were made and what next to do. So first was that. But as we said, like we don't even consider it Angular, so let's skip it for now. But then came Zone.js, which Angular has been using since the version 2 till version 15, 16. It's still using it. It's not like completely deprecated, but they're still using it. So Zone.js, which helped Angular to detect auto-sync operations and then trigger changes accordingly whenever a change was made in one of the states. Then came like from version, I'm not sure about the version, but it came out in recent years, like 2 or 3 years ago. They by default the strategy was on the default. Then they gave you the flexibility to add an on push strategy to the framework. So using on push, you can it will be like it gives you the flexibility when to run the tree, when to run the check to see if something has changed or not. So using on push, it allowed you to re-render only when inputs change or even checker. So there were three conditions basically when an on push will be, or basically on push used to work. It was, and I'll refer to the notes that I prepared here because it's from the documentation. So the first condition is that one of their @ input properties change, like anything is changed by reference. So that time on push will run a change detection cycle to check if something has changed or not. And an event has occurred, like a click or anything inside a element, something has changed or any event has occurred, that time on push will run. And then they gave a flexibility. Let's say there's a very specific situation where Angular is not able to see if something had changed or not, but you know that something had changed there. So they gave you the flexibility of mark for check or detect changes to call these methods, and that time Angular will run a change detection cycle so that you get to know that there was a change made. So even though this was not the best solution, but this helped Angular to build much faster and larger trees, like because there were fewer checks, which means that you have more control over what will happen with the DOM and how to deal with those changes, right? So as I said, like on push was very good, but it still had some issues like manually triggering those mark for check and detect changes. And this mark for check, why mark for check was not good is because consider 1,000 line of code and you have 500 lines of mark for check everywhere, mark for check everywhere. So it wasn't like scalable, it wasn't robust, so it wasn't good. So even though it was solving your problem, solving your use case, but it wasn't the best thing available out there. So that is why they were constantly trying to implement something new, and that's how they came up with Signals. So instead of so what Signals does is instead of rerunning the whole checks or checks for the whole DOM, what it does is it knows where the changes have been made, and it will specifically go and check that particular part of the DOM and then make those changes. And how it does this, we'll see in the further slides. But that's what the evolution has been. Like initially it was the basic digest loop, then it went through Zone.js by default. So when you say that on push, so before on push, it was the default strategy was on default. There was nothing different. It was the default. But now on push is the default strategy. You can change it to default if you want. That's not a problem. But that still exists. And then came Signals. So that's what the evolution history has been. So I think that will help you understand the evolution, the change detection cycle. Just the change detection cycle has went through. Angular has went through a lot of transformations, but yeah, that's one of them. So the next thing, I think we talked about this. So before Signals, it was on push, which improved the performance. So components were re-rendered less often. It was a good approach, but it was still not actually reactive. It was like you're forcing something to react to changes. So it was not the best option out there, but it was solving a use case. There were like global async patches, which were still triggered when you were trying to use Zone.js or whenever change was detected. Then developers had to use mark for check, which we discussed. So in case of on-push change detection strategy, Angular was only running when there were like those three conditions that we discussed before. All right, and one more thing in the topic you might have thought of what is Svelte. I mentioned in the topic like Signals is something like having that Svelte-like performance. Are you all aware of Svelte? I mean, it's kind of new. I don't expect, but I see a few nods, but yeah, it's good. Like I mean. Because it's one of the evolving frameworks that has been coming around. So we'll detour a bit, but let me take it very fast. Sorry if my pace is very fast, but I'll detour a bit here because it's good to understand. So basically what Svelte does is Svelte is not a framework, it's a compiler, and that's how it is different from React and Angular and different libraries. So what it does is it updates only what something truly changes is what their headline is. So basically, it doesn't have something like a virtual DOM diffing or a middle layer which checks if any changes has been made. So what it does is it transcribes or transforms your everything into pure JavaScript. There's nothing like a TypeScript getting converted into JavaScript or something else. It's pure JavaScript. It's like no heavy runtime compilation happening. It's like a minimal zero runtime overhead because it ships heavy frameworks to the browser. Nothing like your packages or those sort of things. Because even React does is React sends React binary files, which compiles at the runtime. So that's how it's different. And basically, it's like very less boilerplate and very predictable framework. I think I had an example. Yeah. So if you see in this example, the left side is usually how you would write a function-based, Angular or a React application for count. Okay, someone else is also giving a talk. So, but the other one which you see the right Yeah, your right side of the screen. So that is the Svelte example for the same thing. If you see that here in the signals, sorry, or Angular or React part, we are calling a method called setState to handle all of the change detection and everything. But in Svelte, if you see, there's nothing like that. There's pure JavaScript, the pure lines of code written. So even though it's more lines of code, you would argue that it's more line of code than how it's good or better than React or Angular, right? But even though it's more line of code, but it's very direct. It's telling the browser that you need to do this and this when this situation is there. So it's very direct. It doesn't let your framework handle the logic for you. So that's what Svelte-like performance. I mean, like everything is very clear. Everything has been made ready for you. You don't need to perform those heavy operations, right? So this is one of the comparison that I want to show. So yeah, that's what Svelte means. Like you don't need any more mark for check methods. Updates happen exactly where the data changes, nothing more or nothing less. The UI reacts automatically, so that's what I mean. That a framework should be, right? You don't need to handle, or you don't need to get in the hassle of maintaining your change detection strategy, right? So if Svelte gets integrated in Angular, it will be, you can say that Angular is finally reactive, which it's still not, but you can say that it's finally reactive, fast and lightweight and predictable, so that it becomes easy. As our job as a developer, it becomes easy. So that's, I just wanted to add comparison here. So this is, I took it from a presentation, the link is below, but what it does is, what it's trying to do is, it shows the how much time it takes, like performance versus the time it takes. So if you see Angular and React, they are on the top of the chart, and the other frameworks, Vue, Solid, all of them, Svelte, all of them are here. So and in this graph, what it means is that lower is better. So if you see the Solid.js, yeah, it's the last one, which has the least time that takes in terms of showing the reacting to the change detections. And why is it? Because Solid.js also uses something called as signals, and that's how Angular picked it from there, that if they're able to solve it there, maybe we can also try. And that's what the next step of Angular became, that using signals can solve the problem. And I think it did. So if we talk only briefly about signals, what it does is, with signals, Angular doesn't have to guess anymore. It actually knows which variable has changed, which component has changed, so that only, and which components depends on it, so that it can update both of them. It doesn't wait for you to tell you need to also update the dependent variables. So the complete part has been updated, and now we decide that when and how the view should react, rather than the change detection cycle or strategy letting or telling you how to react, right? So signals are both smarter and now faster, because Angular already knows what's dirty. So dirty was a term that we were using to tell there's some change that has been made here. So that's what signals can do now. And signals are more life cycle aware. So what does life cycle aware means is, they integrate tightly with your Angular components or services. For example, like let's say an Angular component is destroyed, with an ng destroy or any way you destroy, it will also destroy the corresponding signals that were attached to it. So that's how it becomes more lifecycle aware, that rather than you going and unsubscribing. Let's say there's an observable you have subscribed to, and whenever an ng on destroy method has been called, or the observable has been destroyed, all of those subscriptions would be unsubscribed, and this will be done automatically if you use signals. And that's what signals comes and helps you, that these part are being handled for you. You don't need to manually go and do that. So and this gives us the advantage that it reduces the writing of those boilerplate code. So initially you had to write ng on destroy, no matter because you didn't had to run into issues like browser memory leak or those sort of things. So signals are kind of helping you here. All right, so I think this was like majorly theory, but I think it would make more sense when we see something somewhat relative code. I think that will help us understand the concept much more better. So we'll first try to understand why do we need signals. I think I explained like by change detection and blah blah blah, but let's try to understand in terms of code that why do we actually need signals. So this is a very simple JavaScript code where you can see that A is having value 1, B is having value 2, and C just tells you the sum of both. And if you console log, it will log 3, right? That there's nothing, no rocket science behind this. But what if I try to update the value of A once it has been displayed, and then I try to see the sum? So technically, the sum of C should have been now, it was 2 plus 1, 3. Then A's value got changed to 3. So it should be 3 plus 3, 6. But if you run this piece of code in JavaScript in your console or wherever, it will still show 3 because C didn't get to know that A value was changed. So this is a very simple use case, but consider something having similar in your e-cart application where you added some products to your cart and you tried changing the values of number of products, but your cart value didn't get updated, so your total amount didn't get updated. So this is one of the scenarios that you might run into, and this is where signals, concepts like signals come handy to help you solve these type of issues. So yeah, so this is where I'll come back here, but this is what we'll try to solve using signals. So now we'll go jump to change direction by pacing up a bit. So this code is also very pretty forward if you know Angular. It has like a component. It has like your default change detection applied to it, where it's a counter application, and there's a button. If you click on it, it will display the count, and it will keep on incrementing on every click. So this was the default way that we used to write code. Then Angular came up with something called as on push, where you are able to change. I don't know if, okay, let me try that laser thing. Okay, I don't know. Yeah, it's working. So if you see here, the change detection method, you can specify that the change detection strategy should not be default, it should be on push. And that's how you can, tell Angular, that, you need to use on push now. So, and whenever you use on push, you can, as we discussed, we can give something called as mark for check and tell Angular, something has changed, you need to go and check the latest value of this variable. So this way count's value will always be updated. Right, so this was the on push thing which Angular gave you. So it is super handy that it gives you the flexibility to add mark for check. But just imagine like many number of such methods or number of lines in your code. That's not scalable approach, right? So that is where I think signals can help us. It will work also on push. There's nothing different in that. So here, but whenever we use signals, we need to do some changes. So if you see initially in our, this is a very normal variable declaration. Count was initialized to 0. But whenever you talk about signals, you need to define it somewhat differently. You need to define it as a function, because if you try to console a count, it will show you that it's a signal function. It's not your normal variable. And you need to pass the parameter to initialize the value. That's understandable. But when you try to increment it, so initially the increment was also very simple. It was like this dot count plus plus. It will, okay, I can't see the slides here, but okay. The HTML, yeah, it's working now. So count plus plus, so it was a very simple increment. But here, whenever you want to update the value for a signal, it's not that simple. You need to either call like set, or by which you can increment the value, or there's another method called update, by which you can pass the arrow function to it and tell this is something what you need to update. Now Angular documentation, what it does, it suggests that you shouldn't use set to update the value, because set should be used to set the value. Something like if you want to set the value to 0, for that you should use set. But if you want to update something, you should use the method called update, to which you can tell what you need to update as a method. And notice this also, that this also has been changed when you try to display. So initially it was just you were displaying that variable directly, but if you want to render it in your HTML, you need to change the way you render it. So these are few changes that if you do in your signal, and also of course you need to import it from your core library. So if you do these things in your in your code, so that will help you to use signals and not let you get into situations where the console log thing, that for addition of two numbers that we checked, and it's pretty common. It can happen in a count application also, right? If you are updating the value, let's say count was initially 0, you clicked on plus, then the count got incremented to 1, but the value which is displaying it doesn't know that the count value was updated. So HTML will still show 0. You keep on increasing the count, but it still shows 0 because HTML doesn't know that the value of the count was updated. So using signals, you can actually tell, you can actually, it kind of subscribes, it doesn't actually do that, but kind of subscribes to it and automatically unsubscribes whenever that component is destroyed. So that's what signals come in and help us being handy. So there are like few types of different signals also. There's something called as input signals and output signals. So I'll increase my pace here because I didn't have much time. So as you can see that input, initially we use what, this was the way we used to take input parameters from your parent, and this was the way you used to let your sibling components or your parent component that pass your parameters. That this was the initial way. But if you see now, this kind of becomes simpler, that if you want to pass a value to your, or if you want to take it as a parameter, you can simply pass it as input. And if you want to send a value to your sibling component or to your parent, you can do it via output. And so it's this simpler now. And if you see, the last thing is also for the data model binding that we had. So this means that there's a two-way binding where we can have like a parent component and a child component share the data between each other. Initially also we were able to do that, but kind of simplifies the code and makes it easier for you from your TypeScript to update the values. So and also there's a very interesting blog written on it. Again, it's by Angular, so it's a very interesting blog. If you get time, you should give it a read. And there are like few more reactive primitives that I think if we are trying to get into signals, it's good if we know. So they're like writable signals, computed signals, and effects. So we kind of already covered writable signals, where you are able to update the value of signals. So that's what writable signal is. But if we move to computed signals, so computed signals is something where I mean, in a normal signal, what you would do is you would initially have like count. Sorry. Okay, I'll get to the example directly. So here we have like two variables, like count and double count. Not normal variables. Those are signal variables with us. So writable signal is a count which takes in which is given a value with 0, and then double count whenever it is called. What it will do is it will compute the value for you, and it will increase the count's value to 2. There's so many things that I've written here, but okay, I see that I'm running out of time. But it kind of it is a signal for you. So here double count is something which can't be it's kind of like read only, where you can't manually update it. It can only be updated via this computed method. So that's what computed signals come in handy for, where it's a value where you can't change it directly, only a method can change. So that's where computed signals come in handy. So there's something called as effects. So consider a situation where based on every, let's say count only, like count was our signal variable. So based on this, you need to console log, or whenever that signal variable changes, you need to send it to analytics that these things happen. So that's where signals come handy. It can like track the effect, it can also clean it up when something has been destroyed, and it also knows that which component belongs to. So whenever that component changes, or that particular variable changes, or that particular signal changes, this effect will come in handy and it will know what to do next whenever that has happened. Okay. So again, there are so many things here. Again, this is the Angular dev link. If you are interested, you can actually visit that blog. It's super interesting. You should actually read it. All right. So there's something that I wanted to talk about. Okay, that's me. So, all right. So, this was the problem where we left, where we are not able to get to the latest value of C. Like C should have been year 6, but due to because we are not using signals, it doesn't know that the value of signals value of that variable change. But if we actually use signal, as we saw, like a simple, okay, sorry, as we saw a simple signal problem, simple writable signal and computed signal can help us do that. So if we make A as a signal with value 1, B as a signal with value 2, and C will be a computed signal with the sum of A and B. And when we first try to console log C, it will be 3 because it hasn't changed. But when we try to set the value of A to 3, then it will be console log C. Again, set is the update. Set is not the best way to update the value, but just for simplicity, I added that. And I think this should have been 6, but it's wrong. It should have been 6 because A is now 3, so 3 plus 2, 5 plus 1, 6. It should have been 6. But yeah, that's what signals will help you do that. Signals will help you to always stay updated with whatever the latest value of that state is. All right, I think I had to check. So this was the other half. I'll cover very quickly the other half. I just have like some 5 minutes remaining. So with all of the signals hype that we are trying to say, it actually, we and actually even I got confused. So that's why I added this. So signals are something, it doesn't help you improve like your runtime performance or anything you build or something like that, right? It will make your app faster, but after it's loaded, it won't help you, to make your app once it's built, right? So that's what I want to make it clear, that it's not something which will help you to build your apps faster or the size of your code will be reduced. But I mean, in terms of it can reduce, but not that much, because boilerplate code can be reduced, and it might be an effect, but it will be very like maybe 0.01 kbs worth of effect. But yeah, so the second half was about the build system that was interesting, that Angular decided to change when they changed to signals, and that is why it's related. So the older approach, or the traditional approach that Angular was using, was they were using Webpack, and they was using Webpack to bundle your code. Cursor they were using to minify your code, and TypeScript compiler they were using to transcribe your code from TypeScript to JavaScript, because browser understands JavaScript. So this was the old suite that Angular was using, the combination of these three things. But the problem was, I think, where Webpack. So Webpack was very super handy. Like, I mean, it allowed you to configure your build, how the code should be built and everything like that, and how it should bundle. But the problem with that was it was taking like way too much time. So that was a trade-off that people had to do, like, even though it solves your problem, but again, it takes way too much time. So the builds were slower because the bundling process was slower. And someone on internet summarized all of the issues of Webpack, something called as legacy compatibility, because if you try to, even if the applications have been built, in the past 4 or 5 years, they might be using Webpack and heavily dependent on Webpack. So that's why it becomes like a legacy compatibility when you try to pick on that. So the new system what Angular came up was something called as esbuild and Vite. Sorry, not Vite, it's Vite. So esbuild helped you to do everything. It helped you transcribe your TypeScript to JavaScript. It handled your JSX files if there's. It helped you minify your code, which a separate library was able to do previously. And it also can transform your modern JavaScript to, if there's a older browser which requires a previous version of JavaScript. So it can do it can do that for you. And of course and one more thing is, if you go and check esbuild's documentation, it's really top notch with so many good examples. So that was a, I mean, that wasn't the reason they chose esbuild, but it was because of the performance, because esbuild is actually 10 to 100 times of 10 to 100 times faster than webpack, and that's what esbuild comes in very handy. But esbuild alone wasn't sufficiently enough to let Angular choose or completely dependent on esbuild. That's why they chose Vite. So in case if you have ever done npx React app, create React app, but then you switch to Vite, you might have noticed there's a huge amount of difference in the building of apps, and that is because Vite uses esbuild at its core. So that's how they were integrated. So Angular decided to combine them and migrated to the and choose that as the new system to build and bundle your files. So again, there's a very good link where they have explained the significant architectures for both of the libraries that they chose to choose as the bundling libraries. So that's it. Again, time is very less. So, and this is a very short topic. Like, can we actually, from our side as a developer, help shrink the bundle and build sizes in some or the other way? So it turns out there are a few. One of them is that you change your you upgrade your Angular version to esbuild and Vite. But after that, it's one of them is use something called as deferrable views, and we'll see. Let's directly jump there. So deferrable views. So if initially there's something concept as lazy load, which you might be knowing if you are into front end for a while. So lazy load is something that there's a component which you don't need now, but you know that you might be needing it in the future time somewhere. So that's what lazy loading is. And initially you were able to do it using Angular. There was a way to do that. That was also very too much of boilerplate code and different libraries to do that. But using defer, you can actually, you don't need any additional libraries or things for that. It reduces huge amount of boilerplate code for you. And using @defer, you can actually tell Angular, this is my lazy loaded component, so you don't load it now. And it also gives you something called as placeholder, using which you can specify that while that component is loading, what you need to show it in the UI. So that's also one of the provisions that Angular gives you, and it also gives you a provision to throw error in case if there's any. There's something syntactic sugar that they did. So if you remember, if and fors in Angular is written via ngif and ng4. But again, for that, there was a huge template that you need to follow. But using @if, @for, you can actually reduce your much lines of code. So it's kind of like, if there are like less lines of code, it will help you minify your files faster because there's less lines of code, right? So, and it actually works, it's very faster, and it actually works with signals also. So it's a good way to reduce the file. And this last topic, and there's something called as standalone APIs. So if you remember initially, we had to use ng modules if we wanted to use pipes, directives, and different components from different modules. But using standalone, if you specify the standalone as true, it'll solve you don't need to differently specify that something called as like ng module, where this is a pipe and this is that, and it'll help solve you the problem. So those were the things, and this I added like very last minute. I was adding it right before the talk. So it's just like signal is good. Signal is something very good, but there are certain things where you should consider or should double check before moving your stuff to signals. So it's basically whenever you have like your async pipes out there with a very complex logic. So what will happen is if you signal, if you add your if you add signals there too, what will happen is there will be two change detections parallelly going on, and actually they will complicate your logic more than simplifying it. So that might not be the best place to add signals. Then if you are, maybe having like a very stable RxJS based app architecture, which using which you are very able to easily manage your state and store your stuff. So that's not when you should also add signals, because there's already a logic to manage a state there, and it's way faster than what signals would do. So again, it will be more complication. It will be more of over complication than simplifying it. And of course, it's something. There's something like a global variable, like, for example, there's a theme variable that you're using, that this is the theme that should be followed. But if you bring signals there, so that's not the best thing there. So I think these were the key takeaways, that Angular changed a lot of things. Signals has like a huge amount of reactivity and performance, and there are like modern Angular, the signals which Angular offers, it's like a kind of like a Svelte-like experience where Angular knows what to change when, and there are like new build systems which improves speed, like the esbuild and Vite stuff. So it was that's what the build part was. So again, I thought of adding like a lot of links here, but I think the only link that you should go and check is the Angular documentation. It's one of the best documentations for a framework out there. They have like good amount of examples and good amount of resources attached to them also, in case if there's a need. But that's one of the best documentation that you should follow. I think my talk is done, right? Yeah, I think this was just one code that I follow from one of my late actors. So that's what the is motto that I follow everywhere. And yeah, I think that's it. So this was the last slide of my